Hey guys, so in this video we are going to talk about probability distributions and our graphing calculators. We are going to learn how to create probability distribution charts, how to create probability histograms, so those are the graphs, and how to calculate expected values, so our E of X, all using our graphing calculators. A lot of you probably have a TA84, but I have a TA83. It should be the exact same. Yours will just look prettier and fancier, but I mean, it's not a problem. So let's start. Our charts, how we're going to put the chart into the graphing calculator. So when you have your graphing calculator, you're going to hit this stat button here, and then you're going to go to edit. So just the first one, you're going to hit enter. Now, if you're like me and you already have a bunch of stuff in there, okay, you want to make sure you want to clear all this. So the way to do that is we are going to, so I've just quit from there, and I want to go to second, so it's the yellow button, and then the plus sign, so it says memory at the top there, and I'm going to scroll down to number 4, so clear all lists, and I'm going to hit enter, and then it says done. So when I go back into my stat, so stat, edit, okay, there's nothing there. So now I can start to work with this. So I have an X column here for my random variable X. I'm going to put that into my list 1 here. Okay, so the way I'm going to do that is simply where it's highlighted, that's where I'm going to put the value. So I have 0, hit enter, 1, 2, 3, 4. Okay, so I have my random variables in list 1. Then, and this is the most simple way to do this, in my list 2, I'm going to do the exact same thing. That's just going to represent my probability. I'm going to manually enter the values that I see there. So I put 0.1, put 0.3, 0.5, 0.02, 0.08. Okay, and so I have just inputted my probability distribution that was given to me into my graphing calculator. Now right now that doesn't seem like the most helpful thing, but knowing how to do that will be helpful when we get to our graphing phase and our expected value phase. So that's the simplest way to do that type of input into your calculator. Okay, however, if we are talking about something a little bit more complicated, not just a given probability distribution, and we have, let's say, a binomial distribution, it would be really helpful to be able to just input the formula into this calculator and let it do the probability for you. So that's what we're going to learn how to do right now. When we have a binomial distribution, like we have here, where we have 10 trials and the probability of success is 1 over 6, we know that when we put our, so let's draw something here. So we have a random variable x, our p of x is, so we know each individual p of x will be of the form 10, choose x, so whatever's here, and then you're going to put the probability of success, so that's 1 over 6, 1 over 6, to the power of however many successes you have, so x, whatever that number may be, all the way down, x, and then our probability of failure, so that's 5 over 6, to the power of the amount of failures, so it would be 10 minus x, 10 minus x. Now, in practice, what we've normally done is manually done all of them, okay? But 10 is a lot of trials to go through. So, to learn how to do that on our calculator here, I should put my pen aside, we are going to first clear this. So I'm going to go second, memory, I'm going to hit number 4, I'm going to clear all my lists, that's done. I'm going to go back into my stat, I'm going to edit, and first I'm going to put my random variable x's down the side. Okay, so I have 1 through 10 that I need to put down the side, 3, 5, 6, 7, 8, 9, and 10. Okay. Oh, sorry, I should have added a 0 here. Sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because of course I can have 0 successes up till 10 successes. and I'm going to, in my list 2, so this is where it gets a little bit complicated, I'm going to have it highlighting list 2, and at the bottom, so you can see here, it says list 2 equals. This is where I'm going to put the formula for this binomial distribution, okay? So I'm going to hit bracket, 10, math, scroll over to probability, number 3, choose, and I have 10 choose X. Okay, that's whatever happens to be in that column. Now, in this case, I don't have an X, but I have a list 1. What I want to say is 10 choose whatever value is in list 1. So I'm just going to tell the calculator list 1. So I'm going to hit second. I'm going to hit number 1, because if you can see on top here, make sure you guys can see this, the highlighted or the yellow above the number 1 is actually list 1. So I'm going to hit second, 1, and it'll say 10 choose list 1. Hit bracket. Then I want to say 1 over 6, so 1 divided by 6. Maybe you guys can see better here. To the power of, again, I want to say list 1, so second, 1. Okay, so that's list 1 times 5 divided by 6 to the power of, and I want to make sure I put brackets here, 10 minus x, so 10 minus second 1 for list 1, bracket, enter, and now I have the probabilities for all of my random variable x's from 0 to 10. So that's awesome. That's a really good and quick way to find probabilities for a binomial distribution using our graphing calculator. The only thing that I don't necessarily like about it is that when you scroll down, it doesn't show you the formula that we're using. It doesn't show us the method. All it shows us is this decimal value. And even when you go up to the top here to list 2 again, it actually just lists the values now once you type it in. So it's really hard to go back and correct your work. But nonetheless, a really good tool to have. Now, this is an example with a binomial distribution. You can do the exact same thing with a hypergeometric distribution. Just make sure that you put the list 1s in for the x's in that formula. I will show you guys how to do that in class, but it should be the exact same thing, just with a little bit different and variations on our formula use. Okay, so that was how to do the chart. Now we're going to look at the graph. So how do we actually make this turn into a graph? I have highlighted here that we need to turn on our stat plot. So to do that, we are going to go to second, then we're going to go to y equals stat plot. And mine's already on, but you want to make sure it's highlighted. So 1, stat plot on. And you also want to make sure that it's the third one to the right here. That's the type of histogram that we want. These are not the stat plots we want that one. So make sure that one's highlighted, it's on, we're all good, and we can hit graph. Okay, so my graph has a really nice window setting, but if your graph doesn't already have that, it's a good idea to go to your window setting and make sure that the window setting is appropriate to the distribution we're talking about. So this right now is graphing our binomial distribution where we had 10 trials. So I made sure to say I want my X window settings to be between 0 and 10. And if you'll notice, when I go into my list here, the probabilities don't really go greater than 3.2. Right? They get increasingly smaller, like very, very small as you go towards the end. So, oh, sorry about that. When I go to my window settings, I don't really need the Y, so that's where our probabilities can be graphed, to be greater than anything 3.3 or 0.33. So that's what I put into this window setting. Of course, for each individual question, it should be different. But since it's probability, we know our Y max shouldn't go beyond 1, right? Because the probability can't be greater than 1. So when I hit graph, that's what my histogram looks like. Now, in this case, you'll notice over here for these values, you can't even see them because they're so small. Okay, that won't always happen, but in this case, because the probabilities are so small, you can't even see those. Okay, so that's how you do a graph. And the last thing that we're going to have to do, we're going to learn how to do, is our expected value, okay? This is definitely very helpful to know how to do. So when you go into your list again, so we're going to stat, we're going to hit number 1, edit. We are going to go to that third column. So in class, a lot of the times we create these nice probability distributions where we have our random variable x column, we have our probabilities for our random variable x's, and then we have a third column where we take the random variable x, we multiply it by our probability, and then we fill in this column with x times p of x. And then at the bottom, we add them all together, and that gives us our expected value. So that's exactly what we're going to do. We're just going to do that in our graphing calculator. So our list 1 is our x, our list 2 is our p of x, and our list 3 is now going to be our x times p of x. So what we're going to do is we're going to say list 3, we make sure it's highlighted here up at the top, and we're going to tell the calculator to multiply list 1 by list 2. So I'm going to say second 1 for list 1 times second 2 for list 2. Hit enter. And then all the way down the side here, what I have is that value multiplied by that value to give us this value, right? So 0 times 0.16151 is 0. 1 times 0.32301 is 0.3201. 2 times 0.29 yada 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 is 0.5814, and so forth. And it'll do this all the way down. Now this becomes incredibly helpful when we have even more trials or even more random variables, because it saves us a lot of work. Now, in this bottom section, so I've scrolled down to the bottom and I have just this last bar highlighted, that's where we want to have our expected value. To get this expected value, what we're doing is we're adding all these up. So we're going to tell the calculator to add up column 3 here, so list 3. So we're going to say second, and we're going to go to stat, and I'm going to go all the way over to the math, so make sure math is highlighted. Then I'm going to scroll down to number 5 where it says sum. I'm going to hit enter, and then it'll be sum, and I want to say sum 3, so list 3, that was second list 3, and then bracket and enter. And you will see that I get 1.6667. So my expected value for the binomial distribution, because we've just been working with that question, is 1.667. So hopefully this was helpful for you guys and you learned a little bit about how to use your calculators effectively, and you can refer back to this when you guys get confused. Feel free to keep referring back to this, and hopefully it's helpful. Bye!